Ever wonder how a simple idea in your head turns into an app on your phone? Or how a video game just knows what to do when you hit a button? Well, it all starts with a plan, a really specific set of instructions. So today, we're going to pull back the curtain on algorithmic design and see how those amazing plans get made. Here's the game plan for today. First, we'll get into why computers need instructions for absolutely everything. Then, we'll look at how to create a blueprint for our code. After that, we'll learn the basic symbols, kind of like the secret language of logic. Then we'll put it all together and build a simple plan from scratch. And finally, we'll see how to turn those pictures into words a computer can almost understand. All right, first up, instructions for everything. You gotta remember, when you're dealing with a computer, you can't assume a thing. It needs a perfect step-by-step plan for even the most basic tasks. Okay, let's try a little thought experiment. Imagine you have to explain how to make a cup of tea to a robot. And this robot has literally zero clue what a kitchen is. You can't just say, hey, make me some tea. No way. You'd have to say, pick up the kettle with your right hand, walk 3 steps forward, turn left. You see? Every single tiny detail has to be spelled out. That's exactly how computers think. And what's wild is that we all follow these kinds of plans, these algorithms, every single day without even realizing it. I mean, think about your morning routine. Wake up, turn off the alarm, get out of bed. It's a sequence of instructions you follow automatically to get ready for the day. It's your own personal algorithm. So this brings us to the official definition. An algorithm is just that, a finite sequence of well-defined instructions. It's basically a recipe. Whether you're making tea, getting ready in the morning, or telling a computer how to alphabetize a list of names, you're just creating a clear, step-by-step recipe to get the job done. Okay, so if an algorithm is our recipe, how do we actually write it down before we dive into coding? Well, that's where a blueprint comes in. It's all about visualizing your logic before you write a single line of code. And this quote just nails it, doesn't it? Trying to write a program without a plan is like jumping in a car for a cross-country trip with no map and no GPS. Yeah, you might get there, eventually, but you're going to take a lot of wrong turns and get super frustrated. A good visual plan saves you all that headache. In that roadmap, that visual blueprint for our algorithm has a name. It's called a flowchart. It's a super simple but incredibly powerful diagram that uses different shapes and arrows to map out the entire logical journey from start to finish. So, what does this visual language actually look like? That brings us to the basic symbols. Think of these as the fundamental building blocks, the ABCs, you'll use to build any flowchart you can imagine. Every story has a beginning and an end, right? Well, so does every flowchart, and that's the job of this oval shape, the terminator. You'll always have one at the very top that says start and one at the very bottom that says end. Simple. It just frames the whole process. Next up, we've got the real workhorse of the flowchart, the rectangle. This is the process symbol. This is where the action happens. It's the doing part. Calculate the total, turn on the light, make the sandwich. Any direct command or action goes inside one of these rectangles. Okay, but this is where things get really interesting. The diamond. This is the decision symbol, and it's what makes our algorithm smart. It asks a simple yes or no question, like, is the password correct, or is it raining outside? And, depending on that answer, it creates different paths for our logic to follow. This is absolutely crucial. So let's do a super quick recap of our main players. The oval is our terminator, our start and end points. The rectangle is for a process, that's an action. The diamond is for a decision, a question that splits our path. And you'll also see this one a lot, the parallelogram. That's for any time you're getting input or displaying output. Those are the essentials you'll see everywhere. All right, enough theory. The best way to really get this is to just build one. So let's dive into section 4 and actually create a simple plan together. Here is our mission, and I think it's one we can all relate to. We're hungry. The goal is to eat, but first we have to decide, should I make a sandwich? Let's map this out. Okay, first things first. Every single flowchart needs a beginning. So we draw our oval and we label it start. Now, right away, we have to make a decision, don't we? So we need our diamond symbol. And inside that diamond, we ask the most important question, do I have bread? And this is where that diamond really shines. It has 2 doors leading out of it, a yes door and a no door. If the answer is yes, I have bread, we follow that path to a process rectangle that says make sandwich. But if the answer is no, we follow the other path to a completely different process, order pizza. Now check this out. It doesn't matter which path we took. Making a sandwich or ordering a pizza, both paths lead to the same outcome. So we draw arrows from both of those boxes, and they meet up at one final process: eat food. Once that's done, our job is finished, and we hit our final terminator oval, the end. And that's it, a complete flowchart. So we just created this perfect visual plan. But a flowchart isn't code. It's the step that comes before you code. So for our last section, let's look at how we build the bridge from these pictures to actual written instructions. And this is what's so cool. Look at how perfectly our visual plan translates into something that looks like code. On the left, our diamond asking, "Do I have bread?" On the right, you see this thing called pseudocode. It reads, "If bread is available, then make sandwich, else order pizza." See? The flowchart basically wrote it for us. It makes the next step almost effortless. And that right there is the real magic of it. A flowchart isn't just about drawing pretty shapes. It's a tool for thinking. It forces you to get organized, to think about every single possibility, and to solve problems on paper before you get stuck staring at a confusing line of code. It literally makes your thought process visible. Okay, let's boil all this down. What are the big takeaways? 1. Algorithms are just super precise recipes for computers. 2. Flowcharts are the visual blueprints we use to design those recipes. 3. Each symbol has a very specific job to do: starting, doing, or deciding. And 4, and this is the most important one, planning things out visually first will absolutely 100% help you write better code faster. And it all comes back to that one thing, that one good plan, that one clear idea, visualized and mapped out. It's proof that from a single, simple plan, you can start to build something truly amazing. So I'm going to leave you with a challenge. Now that you have this new tool for thinking, what's the first simple algorithm you're going to design? What's an everyday task you could map out just for fun? Give it a try. Thanks for hanging out with me today.